So, very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 6th students of participant branches for today's session. So, as you all can see on the screen, and you are well aware, my subject is physics. We are in class 6th, our ongoing chapter, magnetism. Today we are entering into the session number 4. So far we completed 3 classes in understanding the basic concept of magnetism, right? So we started from the history of magnetism to the Ewing's molecular theory of the magnetism. So this takes 3 sessions for us. So today we'll continue where we left. But before that, let us recall what we learned in the last 3 sessions. So as you know all, this is a picture which clearly explains us about the prehistory of magnetism. Means how this name magnetism comes, or how this magnetism discovered by a shepherd named as Mangalina in a place called Magnesia, from a stone we can see on the screen, stone called magnetite. So all these names are looking sounds same. So the material is named as magnet, right? So magnet shows so many properties. So like it shows the properties. So keeping we of the properties, the property is named as magnetism, right? It shows the first one is attractive property, very important. So as you know that every magnet attracts the magnetic materials like iron, nickel, cobalt. Then second property is direction property, very important one. As you all know, magnet always shows north and south direction. So this property leads to use the magnets in so many navigation purpose, knowing the direction. And third property is induction property. That means without direct contact also, we can convert magnetic material into magnet. The method is called induction. And very important property is law of magnetism, which shows that like charges repulse, unlike charges attracts each other. Like charges repulse, like poles repulse, unlike poles attracts each other, is the called law of magnetism. So these are the 4 properties studied by the scientists of Greek ancient time. And that properties, because the material which is showing this property is named as magnet, and the properties are named as magnetism. Okay. Then we learn more about the magnet. So we learn what are the types of magnets, like natural magnet and artificial magnet. Okay. Natural, artificial. Natural magnet is a magnet which is exist in nature, like our magnetite and earth. So artificial magnet, there are so many are there. As per our requirement, we can make any type of magnet, like bar magnet, needle magnet, cylindrical magnet, horseshoe magnet, ring magnet. All these you can make as per our requirement, any shape. Then all the materials available are classified based on behavior in magnetic field as magnetic materials, non-magnetic materials. Magnetic materials are those which are affected by a magnet. Either they may strongly attract or weakly attract. Second category is non-magnetic, which are unaffected by magnet or repelled by a magnet. So based on again classification, they are named as ferromagnetic, paramagnetic, and diamagnetic substances. Okay. Then in last class we discussed about the very important theory which explains about the internal structure of magnet. Means why magnet is behaving like a magnet. Why magnet is behaving like magnet. So what is the internal happens? How the molecules are arranged before magnetization after magnetization. So everything is explained by the molecular theory of magnetism, which is proposed by Weber and modified by Ewing. So you can see the points. We can convert the all ferromagnetic substance into magnets. And of course, we can demagnetize them also. We can make the magnet lose the property either by heating or by mishandling or hammering or dropping from certain place, certain height. All these cases makes the magnet lose the property. But whenever magnet is cut into pieces, any number of pieces, 2, 4, 16, 32, any number, each piece exists with the pair of poles. We cannot get separate north pole and separate south pole. We cannot get the isolated poles. It always exists with the pair of poles, right? This is completely explained by the molecular theory of magnetism. Further explanation will come across in the higher classes. So today we are discussing is about the synopsis number 2. You can see here 2 important definitions: magnetic field, magnetic lines of force. Right? 2 important words: magnetic field, magnetic lines of force. Okay. So what is magnetic field? For example, we have magnet with you. Right? We have one magnet, north and south pole. Right? We have one iron. Right? We have one magnet and one iron. So magnet, by keeping magnet here, if you keep iron at 1 kilometer distance, it won't attract. Attracts? No. It has certain range. Suppose around the magnet, there is some region, some space where the effect of magnet is there. By placing magnet on table, take the iron and see where up to where it is attracting. Suppose when you are moving the iron to some more distance, it won't attract because that magnet is having its own region. The region or space, you can say, the region around magnet, region or space, the region or space around the magnet where its effect is felt is known as magnetic field. So every magnet has its own field. For example, say chief minister is there. So who is the chief minister? What is the chief minister range? Only that particular state, right? So for example, Revant Reddy is the chief minister of Telangana. He cannot go to the Andhra Pradesh and he can order for anything because the Revant Reddy range is only Telangana state. Similarly, Chandrababu Naidu only Andhra Pradesh state. Similarly, Narendra Modi is the entire India. He cannot go to America and say that do this, because his range is only within the India. Similarly, every magnet has its own region around it where its effect is felt. That region, that space is called magnetic field. The space around the magnet where its effect is felt. Okay. So magnets exert force, attraction. So you can see here. So hope you understand region, field. So what is saying? Magnet, force, attraction, anything made of iron. Anything made of iron will be attracted to the magnet. A magnet will often not attract things that are not made of or do not contain iron. However, scientists have developed and discovered the material that are non-ferrous, no iron, that will act as a magnet and attracted to magnets. So they are artificially prepared. Look at the magnet above. It is called a bar magnet. So this is bar, which is a rectangular shape. It has 2 ends. The end labeled as N means north and S means south. These 2 ends are magnetic poles. So why you are calling them as poles? Because there is a maximum attracting force is there, the 2 ends only. You take one magnet, take some iron pieces or any sand also. You can drop the magnet in sand and take out. What you observe is maximum iron fillings attract at the 2 poles only. Very less we can find in the body of the magnet. So that means attracting power for the magnet is more at the 2 extreme ends of the magnet. those extreme ends are called poles of a magnet, which are named as north and south poles. Right? The earth, like a giant magnet, the magnetic fields surround the earth are near north pole and south pole. That's why the poles of ends of bar magnet are called north and south. Okay. So see here, when north and south pole are placed, they attract. When you place south-south or north-north, they repel. Unlike poles attracts, like poles repels. Is called law of magnetism. Right? So this is about the field of magnet. So that is, so you see how use of the magnet in finding the direction. I told already, we discussed that there is a compass which contains the magnetic needle. It is useful for the navigation purpose or for knowing the direction. Okay. So actually, to showing the direction, it is used. Okay. Very useful in finding the direction, the needle. So whether it may be on road or water or air, everywhere we'll use the magnetic needle or magnet for showing the direction, which is called navigation purpose. Okay. That is magnetic compass or magnetic needle. Okay. So before going for the next, some few terms are there to define, like magnetic pole, magnetic length, that is length of magnet. Okay. We'll go for one video I'll show me which explains about the what is magnetic field and what are the magnetic lines. Right? After the video, we'll continue.
Hello students, welcome to the physics session. My name is Bhavna and today we are going to learn the topic of magnetic field and magnetic lines of forces. This falls under the unit of magnetic lines of forces and magnetic field under the theme of magnetism. Now students, you may have observed that you can attract an iron nail or any magnetic material towards a magnet even from a distance, right? That means you do not have to go and touch the magnetic material to pick it up. Now, why or how does this happen? The reason for this is the magnetic field and the magnetic lines of forces. That means a magnet has a tendency to attract the magnetic material even from a distance because it has an influence around its vicinity. That means a magnet has the magnetic field around it. So anything that comes under the magnetic field of that magnet, inside that magnetic field, it gets attracted to the magnet. So let's begin with the definition and then we'll do one more activity to understand how we...
So you write down this definition for magnetic field. Okay, note down. Magnetic field, the space around the magnet where its influence can be detected is called the magnetic field. Note down it as a synopsis, right? Please, all of you. So this is about what is magnetic field, means space. I already told so many examples for you. The space around the magnet where its influence or its effect can be detected is called magnetic field, right? Written. I'm moving. Okay, next.
Get the meaning of magnetic field. Now, magnetic field is defined as the space around the magnet where its influence can be detected. That means the place or the area around the magnet in which any magnetic material comes, it will get attracted to the magnet. So, the space around the magnet where its influence can be detected is called the magnetic field. Now, how we can understand how magnetic fields are formed? We need to do an investigation. In this investigation, you need to have a white paper and some iron fillings.
iron pieces.
Now, what are iron fillings? Iron fillings is nothing but iron dust.
Dust.
So, when you have iron dust spread over your white sheet, you are going to see how the magnetic lines are formed. In this experiment, we are going to spread some iron fillings on a white sheet over a drawing board. Now, once you do this, place a bar magnet in the center of the drawing board. Now, what will you see? Slowly and steadily, the iron fillings form a pattern.
See, they are arranging the shape.
Form a pattern around the magnet you had just placed. These pattern which you are able to see is nothing but the magnetic field of the magnet. That means till the point all these iron fillings, arrange them into a pattern. Till that point, the influence of that magnet can be felt. So, anything that comes in that influence will eventually get attracted to the magnet. Okay, students? Now, if I draw a picture of how the iron fillings get arranged in a pattern, this is the pattern that you observe. You observe that the iron fillings are more near the pole of the magnet. So, near both the pole, you will see that the iron fillings are forming some circular shape. And from the pole, you can see there are some concentric circles drawn from both the poles of the magnet, right? These things are defined as the magnetic field. Now, how do we define it? The iron fillings move and reposition themselves because they are affected by the magnetic force of the bar magnet. So, this is the reason why my iron fillings are arranging them in the pattern that you can see in the image, right? Now, what are the various properties of these magnetic fields? These magnetic fields are filled with the magnetic lines of forces. Now, we already understood.
Please note down this point also. What is the magnetic lines of force? I'll explain it later. The path along which iron fillings readjust in magnetic field will be magnetic lines of force. The magnetic lines of force are highly concentrated near poles. Means they are more at poles compared to the body of the magnet. Please note down this as second point. So first you wrote about magnetic field. Now about magnetic line of forces. The two important points we are discussing today. Explanation you can see and I'll explain later after the video. The path, that is magnetic lines of force, is the path along which iron fillings will readjust in a magnetic field will be magnetic lines of force. The magnetic lines of force are highly concentrated near poles. Right.
What are magnetic field? Magnetic field is the area around the magnet through which its influence can be felt. But these magnetic field, the influence of the magnetic field is affected by what, students? They are affected by the magnetic lines of forces. So, we can say in a term that the magnetic field is filled with the magnetic lines of forces. So, the lines, the pattern you are observing is nothing but they are the magnetic lines of forces. Now, what do you observe is written here. The path along which the iron fillings readjust in the magnetic field is the magnetic lines of forces. These magnetic lines are highly concentrated near the poles and they form concentric circles from the or in between both the poles of the magnet. Right? Now, we observe that what is magnetic field, right? How these magnetic field are filled with the magnetic lines of forces. Where they are concentrated more, where they are concentrated less, they are forming circular pattern. But we do not still know what is the direction of these magnetic lines of forces. Now, to understand that, we again have to conduct one more activity. Now, in that case, the activity will
Very
take
interesting,
three
easily you can
things.
do.
One is a white sheet of paper. Two is a bar magnet.
Yeah,
Whose
you can do in school also.
north and south is known. Okay.
Compass.
And third is small directional compasses. Now, once you have all these three components, you can test where the lines of forces are moving from. Now, in this experiment, you have to place your bar magnet in the center of the white sheet, and if you do not have a number of directional compasses, you can take one and then place it over all these positions. So, don't take it as number of compasses. These are the position of the compass that you need to place. So, after 1, you have to place it at 2, then 3, then 4, and then so on. Right? So, if I draw a pattern over here, you can see what you need to do. You have your magnet. You first place your compass as position number 1. In this position, the 0 position shows your south direction and your 1 position shows your north direction. Once you are done with this position, you will pick your compass and then you will place it on the second position, then on the third position. So, you are picking up your compass and you are drawing the lines as the direction is shown on the compass. You will observe, students, that as you move last position, your compass will be pointing in a direction that is inward the pole of the magnet. In the first position, it is moving outward. In the last position, it is moving inward. So, in one way, on drawing these lines, if I just pick my compass and draw this in a line, how things are working, then I'll get such a pattern. What a pattern is this? In the end, in the edges, my magnetic lines of forces are moving out. And actually, if you can make, they will also make a circular pattern and they will enter the other end. In this case, you will observe that the pattern that we are observing, that they are coming from one side and moving in the other side, it is the north, coming out of the north direction and going inside the south direction. On drawing the magnetic lines of forces, as you can see here, you will see the pattern so observed in a following manner. Right, student? So, from the north pole, the lines are moving out, but in the south pole, the lines are moving in. Okay, students? So, the final image that you observe will be such an image. The pole lines, the magnetic lines are moving out of the north pole and they are moving inside the south pole.
So, write down this also. Definition of magnetic line of force. Note down. It is closed continuous curve in a magnetic field along which the north pole will move with the free to do so, and its direction given by direction in which free north pole will point. I will explain you this. So, lines of force always starts from north pole and they terminates at south pole. Means away from north pole towards south pole.
Right? And in between, we get concentric circles. So, after doing this experiment, we can have a better definition of magnetic lines of forces, and it is given here, students. It is closed continuous curve in a magnetic field along which the north pole will move if free to do so. These are the field lines in which the pole will move if it is free to do so. And its direction is given by the direction in which the north pole will point. So, after doing this experiment, students, we can say magnetic lines of forces are those lines of forces in which the north pole will move if it was free to do so. Okay, students. Now, when we learn about magnetic lines of forces, we have to learn about various properties of magnetic lines of forces.
Very important.
The various properties of magnetic lines of forces are...
Right, note all this. They are closed continuous curve They travel from north to south outside the magnet and form south to north inside the magnet that I have explained. They contract laterally, that is, they bend along the length of magnet. They mutually repel each other. They never intersect with each other. These are the 5 important points of the magnetic lines of force. You note on them clearly. Very important. See, this video completely explains about the both the topics what we are discussing today. Magnetic field, magnetic lines of force, which are related to each other. Okay.
Hence, here they are closed continuous curve. Now, as we already observed in the above experiment, magnetic lines of forces are closed continuous curve. They do not break in the between. The second point says they travel from north to south outside the magnet and from south to north inside the magnet. That means if I have a magnet here and this is my north pole and south pole, my magnetic lines of forces are coming from north to south from the outward. But if I say they are continuous curve, then the field lines will be continuously moving inside the magnet also. Right, student? So in this case, they are moving from south pole to the north pole. The third point says they contract laterally. That is, they bend along the length of the magnet. That means if I have my magnet here, then they are going to contract at the length of the magnet. At the length, they are slowly contracting. Then point number 4 says they mutually repel each other. Now, magnetic field lines will not cross each other ever because they are repelling each other. Each line is an individual field line that will never cross another line. Okay? And they never intersect with each other. So these 2 points come together, that they repel each other and thus they never intersect each other. Okay, students? Now, the last is, if I use a horseshoe magnet, how my field lines will look. Now, here we already have an image of a horseshoe magnet. If the experiment that we had done before is described using a horseshoe magnet, the pattern of the magnetic lines of forces is obtained as shown here. In this experiment, we understood that magnetic lines of forces always go from north to south, right? And they are continuous curves. So, even if I change my magnet, my properties of the magnetic lines of forces does not change. In this case also, the magnetic lines of forces will be from north to south. And they will be concentric continuous curves as described even for bar magnet. Okay, students? Thank you.
So that is clear explanation about both the important topic, both the important terms in magnetism, that is magnetic field and magnetic lines of force. Right? So, right, before going for further explanation, just see here some important terms are there related to magnet or magnetism. So, making your magnetic compass, we know compass is nothing but needle, which contains the needle and covered by the box. Making your own magnet, you can make our own magnet also. Help of a permanent magnet can be prepared by using the ferromagnetic materials, right? So the magnet should be kept in a place always. How to store the magnet? Storing of magnet is very important. So in between you have to leave some non-magnetic material and you have to place in a box. Otherwise it loses the magnetic property. So magnet should be kept away from the speakers, CD, television, music systems. Why? Because they also contains the magnet. So these magnets is influenced by that magnet and it loses the magnetic property. So they should keep separately in a box and separated by a non-magnetic material like wood or rubber. Okay. So next, some definitions are there. See here, pole. You know, the two extreme ends of the magnets are called poles of the magnet. Right? That is, each end of the bar magnet is called its pole. End of the bar magnet means extreme ends you can call. Geometric pole. So geometric, what is the geometric length? Length from the this end to this end is called geometric length, right? This is called geometric length. But what is the magnetic length? Magnetic length is from, there is a molecule to be there. Molecule may not be up to here. So maybe from here to here. The distance from the two ends of the poles is called geometric length. So there is a difference is there between geometric and magnetic length, which we'll discuss in the next class. Right. So apart from this term, there are some more important terms are there to discuss. So see, this is a beautiful diagrams of lines of force, magnetic lines of force. See how they are like curves. Why they are curving? Because the magnetic field strength is changing. Where it is increased, go up. Where it is decreased, come down. So magnet depends on the magnetic field only. We can draw the magnetic lines of force. Either you are drawing for North Pole or South Pole. What we observe is it is always, they always comes out from the North Pole and terminates at South Pole, outside the magnet. Very, very important. See here inside the magnet, how they are showing. They are passing from south, coming out from north. Because they are concentric circles, like that they move continuously. Right? Very, very important property of the magnet is. So that's all for today. So wish you all advance Happy New Year 2025, all of you. Okay, with a beautiful picture. And this is the homework for today. Define magnetic field. You write down the question and write the answer for that. Define magnetic field. You already written as a synopsis. So that's all for today. Thank you very much, students. Have a wonderful day. Thank you.